interesting case is where we have the exponential function. Remember that for a constant function, so let me write this down. When we have a constant function, f of x is equal to c, f prime of x is equal to 0. Then we have f of x equals to mx plus b, f prime of x is equal to m. If f of x is power function, x to power n, then f prime of x is equal to n, x to power n minus 1. What if we have exponential function? What if f of x is equal to b to power x, like 2 to power x, a half to power x, 3 to power x, 5 to power x, and so on? How do we find the derivative of this function? The derivative of this function, you just copy down the function itself and multiply it by ln of the base. So you must have ln of base next to exponential function. That is the derivative of the function. In the easiest case possible, if you have Napier number, if f of x is equal to e to power x, officially the derivative of the function is e to the x times ln of e, but ln of e is equal to 1. This is 1, so you get e to power x back. If you have multiplication of two functions, the way that you're taking the derivative is you take the derivative of the first function multiplied by the second function plus the derivative of the second function multiplied by the first function. The rule is easy to follow. For example, here I have x squared times 9x plus 2. I want to take the derivative of this function. Well, here we have an interesting case. You could distribute x squared into parentheses and take the derivative, or you can apply product rule. So let me show you both ways. Here, this is my f, and this is my g. So h prime of x is f prime times g plus f times g prime. So f prime, the derivative of x squared is just 2x. The derivative of g is just 9. G is 9x plus 2 plus f of x, which is x squared times 9. If you simplify this, you get 18 x squared plus 4x plus 9x, or basically you get 9x squared, you get 27 x squared plus 4x. As I mentioned before, you can distribute and take the derivative using the summation of two functions. Here you have 9x squared times x, let me just write down the whole thing, x cubed plus 2x squared. And the derivative of the function is 9 times 3, x to power 3 minus 1, plus 2 times 2, x to power 2 minus 1. So h prime of x becomes 27 x squared plus 4x. The results are exactly the same, right? It doesn't matter which method you apply. If you feel comfortable using the multiplication of functions and the derivative, apply that method. If you decide to distribute and then take the derivative, that's fine as well. So sometimes it's easy to deal with functions. Some other times it is a little bit tricky. For example, when you have x times e to power x, how do you take the derivative? Well, here we need to find the derivative applying the multiplication. So to take the derivative of this function, f prime of x, we are taking the derivative of x multiplied by e to the x plus x times the derivative of e to the x. We have to use the product rule. Well, the derivative of x is just 1. You're going to copy down e to the x plus x times the derivative of e to the x is e to the x. This is one of those nice functions. Their derivatives are equal to the actual function. So f prime of x is e to the x plus x times e to the x. We could write it nicer as e to the x multiplied by 1 plus x. So that's how we apply the product rule in different scenarios, different situations. So f prime of x is e to the x times 1 plus x.